this, and it's the binomial theorem. The binomial theorem gives us another way to generate the coefficients. So you could use Pascal's triangle, or we could do this. To use the binomial theorem, you need to know how to do factorials, right? So if you recall factorials, you should have learned it at some point. So basically it looks something like this. If you have 4 factorial, okay, this is 4 times 3 times 2 times 1. All right? If you have 3 factorial, it's 3 times 2 times 1. Okay? Now if you have something like 4 factorial over 3 factorial, well, this is 4 times 3 times 2 times 1 over 3 times 2 times 1. And all of these cancel, so you're left with a 4. Okay? That's how it works. One other thing that you need to remember is, what is 0 factorial? 1. Good. There's a proof for it. Just take it as truth now. But 0 factorial is 1. Just like anything to the 0 is 1. 0 factorial is 1. Okay? All right. So that's how we use factorials in generating the coefficients for the binomial expansions. And the equation or the formula is this. Now, this is something out of stats, which, like combinations, permutations. You'll learn it in Algebra 2. You may or may not have covered it. It's really not a big deal if you've never seen it before, because we're just going to plug it into an equation. That's all. All right? So that's how you use it. Now, how does this work in reality? So basically, you do this. You have a C. Now you have your N and your R. N is the exponent, right? That exponent. That's N. And R runs from 0 to N. So if your exponent is 3, then R is going to go from 0 to 1 to 2 to 3. Okay? So let's do A plus B cubed using the binomial theorem. Here's how you do it. You have your C, right? And you start with 3, because that's your N. 0. Why 0? Because R has to go from 0 to 3. And then the next one is C, 3, 1. And the next one is C, 3, 2. And what's the next one? C, 3, 3. So do you see what happened? Why is this number a 3 here? Why are all these 3s? Where do you get it from? Because that's the exponent, and this just goes from 0 to 3, to that number. Not yet. Now I'm going to put in the terms. The terms are, just like before, for the A, it's going to be A cubed, A squared, A to the 1, A to the 0. That's what we were doing before, right? And B's exponents start what and go to what? B to the 0, B to the 1, B to the 2, B to the 3. Now, at each of these, now you're going to plug each of these into the formula. And the formula is this, okay? So on top you have N factorial. Now remember, this is your N and this is your R. So on top you have N factorial, which is 3 factorial, okay? And then you do 3 minus 0, 3 minus 0, 3 factorial, and that number, 0 factorial. Now I'm going to do the other one. Watch. Now I'm going to do this one. On top, you always have the first number factorial. On the bottom, subtract the 2 numbers. 3 minus 1, what do you get? 2 factorial. And what's that second number? 1 factorial. Okay? Okay, so let's do this one. On top, you always have this number factorial. Now you subtract 3 minus 2 and you get 1 factorial, and then you put in the second number. Right. Okay, so let's do this one. What do we have on top? 3 factorial. What do you have on the bottom? 0 factorial, right? And then 3 factorial. Okay, so it's always this minus this, and then the second number. This minus this, and then the second number. All right? Now we're going to put in these. Okay, so here I have a cubed, and b to the 0 is just 1, plus a squared b, plus, what do I get here? A, not cubed, a, b squared, and here I have b cubed, and there's a plus in the middle. Huh? Well, it's these, a squared times b. A times b squared. I'm just copying them. This is 1 times b cubed. Now I'm going to do the math here, okay? So what is 3 factorial? 3 times 2 times 1 over, what is 3 factorial? That. And what's 0 factorial? 1. Plus, what about this one? I have 3 times 2 times 1 over, what do I have? 2 times 1 times 1. Okay? And here? Right, because 0 factorial is 1. Now, everybody, look up here for a minute. What do I have on top here? 3 times 2 times 1. What do I have on the bottom? 1 times 2 times 1. Here, what do I have? 3 times 2 times 1 over 3 times 2 times 1. So here I have a cubed plus a squared b plus ab squared. Oh, this is an ab squared. And then a b cubed. So now let's cancel anything that can be canceled. Like all of these give you a 1. A cubed. Yeah, it's just a harmless one. You don't even have to write it really. Okay, here what cancels? These, so you just have a 3 left. A squared b. And here the 2's go away. You have 3 ab squared. Plus all of these go away, so you have 1b cubed. And there you have it. What would Pascal's triangle have said for the coefficients for n equals 3? It would have said 1, 3, 3, 1. Right? Which is exactly what we got. Okay? Now, yeah. Just one other thing. If you look at this step here, you have 3 factorial over 3 factorial. Could you have just said, oh, you know what, that's just 1? Absolutely. We didn't have to write 3 times 2 times 1 over 3 times 2 times 1. Right here, I can say, oh, that's just 1. That's just 1. Okay? We can do that because anything over itself is just 1. All right. So you are able to use this with, you can use your calculator on this. So if you look at your calculators, what we're going to do is, all right, so I'm going to take one of these. Suppose I take this one. This one here. All right, so just C 3, 2. Okay, now what did I get when I did it manually? I got a 3 for this one, right? Right there. All right, let's see how we do it on the calculator. This is your N, and this is your R. You type in the N. In this case, it's a 3. Now, look here. You go to Math, math. This tab is the probability tab. So you have to press the right arrow to get there. 1, 2, 3 times. Now you want this, NCR. So you select option number 3. And now you need to type in your R. Enter R. R is what in this case? 2. Enter. That's your answer, 3. Right? Now, suppose I wanted to do, right, so that is a 3. Now, suppose right after that I wanted to do 3 and 1, right? I don't type the whole thing over. I say second, answer. I go over here, and I edit into a 1, 3. Okay? And like that, you could put any number. You could do 0, second, enter. Okay? We're good? So that's how we do it with the calculator. All right. So here, now it says to find the coefficient. Now here's another one with a 10. It says to find the coefficient of the indicated term. So we just want the coefficient of the indicated term. All right? So let's go here. We have a minus b to the power of 10. Now what is 10? What variable is 10? Is it n or is it r? N. So this tells you that n is equal to 10. Now, what about r? No, hang on. What about r? Okay? R is, okay, so we want the fourth term. The fourth term. So if r starts from 0, 0, 1, 2, 3, right? So r is what? 3. So for the fourth term, r is equal to 4 minus 1, 3. Now, the way the form looks is this. It's C, N, R. And how do the variables look always? You have a to the something and b to the something, right? Well, the way it is, it's n minus r for the a and b to the r. Okay? So look at this term. Look here. Okay, look at this one. N is 3 here. N is 3. R is 1. What's the exponent of the first one? N minus R. What's the exponent of the second one? R. Always. That's how it's generated. All right? So let's go back. And here's how we're going to do this. This is now C. N is 10. R is 3. Now, A stands for the first term, A, to the power of n minus r, 10 minus 3. And what's the second term here? Is it b or negative b? It's negative b to the power of r, which is just 3. So now, if you plug that into your calculator, 10C3, all right? So we're going to go 10, math. Now look, if you want to go to the probability tab, rather than going to the left, to the right 4 times, you could just go to the left once. That's just a little trick, okay? And then 3, and what is my R? It's 3, enter, 120. So this is 120. Well, hang on, it's 120. I'm going in steps. A to the 7, and here I have negative b cubed. And the negative will come out, so it's negative 120, A7, b cubed. Now this is the fourth term. If you were to expand it, that will be the fourth term. What is the coefficient? Right. And that's your answer. Okay? Now, look at this one. We need the coefficient of this term. Okay? So remember, it was C N R, and then it's A N minus R B R. That means this number is N minus R. Okay? How much is N? The exponent is N. 8. Well, how much is R then? 8 minus R is equal to 7. R is equal to 1. Okay? So now, this will be C, 8, 1. Now, what is A in this problem? A is the 3x. What's the exponent of the 3x going to be? It's N minus R, so it's how much? 7. B to the power, B is how much? Negative 4y to the power of 1. So now let's generate the coefficient here. If we plug that into the calculator, what do we get? It's 8. Right. 3, 1. So that part gives me 8. Times 3 to the 7 times negative 4, x to the 7, y1. Right? I'm moving them out. So now, it's 8. This is a negative multiplied. So we have 8 times 3 to the power of 7 times negative 4. Yeah. And negative 69,984. That's the coefficient. Okay? Now we're going to do this last one, expansion, using the binomial theorem and with the calculator. All right? So let's do this. All right. So how much is N in this problem? 5. So here I get C, 5, and what's this number going to be? 0. Plus C, 5, 1, plus C, 5, 2, C, 5, 3, 5, 4, 5, 5. Right? Now, what about the variables? So here my first term is 2t. So I get 2t to the 5 to the 4 cubed. This step is exactly identical to what you were doing yesterday. Squared to the 1 to the 0, and then I get the 3u. Whoa. 0, 1, 2, 3, 4, 5. Okay? All right, now, what is this going to be if you plug it into your calculator? Plug it into your calculator. What do you get? 1. Is that right? Does Pascal's triangle say the first coefficient must be a 1? It sure does, so that's a 1. Now, 2 to the 5, 32. T to the 5, right? The green one is just 1. Plus, what does the calculator say for this one? C5, 1. 5 times 2 to the 4, 16, times 3, t to the 4, u. Plus, what does the calculator tell us about this? C5, 2, 10. 2 cubed is 8. 3 squared is 9. T cubed U squared plus, what does the calculator tell us about this one? 10 again, times 4, times 27, T squared, U cubed, and here we get a 5 with the calculator, times 2, and 3 to the 4 is how much? Right? T U to the 4. And what do we know about the last coefficient always? It's always a 1. And that green one is a 1. 3 to the 5 is 243 because we just know that. U to the 5th. Okay? And then if we just simplify a little bit, we get 32 T to the 5th plus 15 times 16 is what we said? 240 T to the 4U plus 8 times 9 is 72, so 720. $15 times 16. Okay, so this one now, 40 times 27, 1080, right? Plus 810. Do not make the mistake of thinking that they're always going to be symmetric, because if you've got coefficients here, then that symmetry sort of gives a... Well, only Pascal's coefficients are symmetric, right? Like the 1, 5, 10, 10, 5, 1. Other than that, no. So 810 TU to the 4 plus 243 U to the 5th. And there is binomial expansion using the binomial theorem. Okay? So the homework due tomorrow, right, the homework due tomorrow, Wednesday, will be these. No, 11. But listen, follow the instructions this time. But you didn't follow the instructions. So now this is the homework due Wednesday. And follow the instructions.